Alright guys, this is Algebra 2 Pre-AP Review for test. Polynomials test to be exact. And I'm just kidding, I'm not going to do that. Okay, so we got a review, pretty basic stuff. Just make sure that while you're doing this you understand why these things are happening. I'll try to explain the best I can, without questions coming in. But yeah, so number 1 and 2, right? Pretty simple. We've got to first do standard form, meaning that our exponents have to descend in order. Exponents in descending order. Right? So we've got to put them in descending order. So our highest one is x to the 5th. Right? X to the 5th, so that goes first. That gets crossed off. Next is negative x to the 4th. Right? That gets crossed off. Next would be negative 2x squared. That gets crossed off. Next is negative 4x to the 1st. I'm just not going to write to the 1st. That gets crossed off. And then we have to add 12. Pretty basic. Right? Just make sure that you don't forget a term. Make sure that you're putting these exponents in descending order. 5, 4, there's no 3, 2, and 1, and then 0 is the constant term, right? So make sure you're doing that. Degree is the highest degree, which we already said is 5. Highest degree is 5. Okay. Type is going to be odd, right? And then leading coefficient is going to be right here. There is nothing there. That means it's positive, positive 1. But positive is all we care about. Positive. Well, really we should write positive 1. Right, so leading coefficient is 1. That is positive.
How's the redistricting affecting y'all?
It didn't affect too much. It actually
Pretty much keep the same teams.
Yeah, we just lost Brandeis and Clark, and we gained Harlan for next year. So it'll be about the same stuff. Nothing different.
Nothing drastic.
Yeah, they were talking about putting South San and
South San just gets shitted on
yeah,
every year.
they really do.
They can't be in the same district with Judson, Steele.
Exactly.
It's ridiculous. Them
Yeah.
poor guys.
Yeah. So
They should be in there, even though their numbers say 6A, and it's probably 6A by about 25 students.
By no one. Yeah.
Yeah, but that's, we can't get that many kids participating. But they should put them in Harden. It's always been, I went to McCollum. It's always been Hardendale, McCollum, South San.
Yeah.
It's always been a big rivalry.
Yeah.
We always had a blast.
And they just keep getting moved around everywhere.
And now they're playing Steele, Judson.
Yeah.
It's just crazy.
Okay, sorry guys. Sorry about that. We had a visitor come into the conference room that I am working on. So yeah, but number 2 should be pretty easy. You just write it in standard form, get the highest degree, the type is even, right? And the leading coefficient is 2, which is positive. And so there you go, right? Number 3, okay. So this is the one that might give some people a little bit of trouble since it's the newest thing. But as long as you remember some key points, you'll be fine, right? So increasing or decreasing. Critical points here are local, max, or min, right? Local max or min. That's all we're worried about when it's increasing or decreasing. Those are going to be our critical points. So let's come over here. Let's work with those critical points. My local max and min, my local maximum's right here. Local minimums right here. So we have 3 intervals we're worried about, right? Before this interval is, I will write it actually a little bit further down. So this first interval is negative infinity to, I'm just going to call that negative 1/2. Okay, as long as you have the same critical points as me on the graph, then you're okay. I'm just going to assume that this is 1. Right, and this is 1 since those are the only tick marks that we have. Yeah, so that works. So that's about negative 1/2. So that's an interval that I have to place somewhere. another interval I have to place somewhere is in between the two. So from negative 1/2 to about, I'm going to call that 1/8 just for fun. You can call it whatever you want. As long as you have the same points as me, you can call it whatever you want, right? Because on the test, it'll be a little bit more exact, so there will be no room for error. And then we have this last interval over here, 1/8 to infinity. So those three have to go somewhere, right? So let's come over here. My first interval, negative infinity to negative 1/2, is clearly increasing, right? This is going up, right? It's going up there, so it's increasing. So my first is going to be negative infinity to negative 1/2. Right, my second interval is going to be negative 1/2 to positive 1/8. That is decreasing. It's clearly going downward, right? So my next interval, negative 1/2, oh my goodness, half to 1/8. It's going to go there. And then my last interval, 1/8 to infinity, clearly it's going up. Right, clearly it's going up, so it is increasing. So I put the little union, 1/8 to infinity. All right, so those are your increasing and decreasing. Remember, those critical points only have to do with your local maximum and your local minimum. Next thing we worry about is positive or negative. So positive or negative, our critical points here for these two, our critical points for these two are just x-intercepts. Oh my gosh. So I can't put my palm on the thing because then it won't read it. So it's hard to write. So x-intercepts, right? My x-intercepts, I'm going to redo, even though they're already there, is there, there, and there. Giving us 4 intervals to choose from. I have this interval, I have this middle interval, I have this middle interval, and then I have this big interval to the right over here. So I have 4 different intervals. So let's zoom in here and talk about these intervals here. So this first interval comes from negative infinity and goes to here, which is about negative 2/3. Right? That's the first interval I'm worried about. Then I have this in-between interval, which goes from negative 2/3 to about negative 1/3. Then I got this other middle interval right here, which goes from negative 1/3. Jesus, negative. Can't write. Negative 1/3 to about 1/2. Then I got this last interval over here from 1/2 to infinity. Right, so I've got 4 intervals to place here. So let's talk about it. This first interval on the left here, this one, that's clearly below the x-axis, which means it is negative. So it goes here, negative infinity to negative 2/3. My next interval is this one, negative 2/3 to negative 1/3. This one here, that's clearly above the x-axis. So it goes in the positive one when f of x is greater than 0. So here, I write my negative 2/3, to negative 1/3. My next one is negative 1/3 to 1/2. That is all below the x-axis. So that goes here, union, negative 1/3. Sorry, I'm writing really bad, but I'm also talking, so you're fine. Negative 1/3 to 1/2. And then my final interval is this last one, which is clearly above the x-axis and will be forever. So I've got 1/2 to infinity. All right, and that's it. One thing I didn't mention, this is just a fancy way, guys, of saying positive and negative, or above the x-axis and below the x-axis, right? That's just fancy ways of saying that. Nothing more, okay? Describe the degree. Well, we learned this before. If I have different in behaviors, as my x goes to negative infinity, my y goes to negative infinity, and as my x goes to positive infinity, my y goes to positive infinity. So my degree has to be odd, right? Odd's the only one with different in behaviors. The leading coefficient should be positive. And if I'm to describe the in behavior, let me erase this stuff. Just erase that. So I already described the end behavior, but that's okay. As x goes to negative infinity, or as x goes left, my y goes to negative infinity as well. It goes down. And then conversely, as x goes to infinity, or as x goes right, then my y goes to positive infinity, which is up, right? And so yeah, there you go, right? As x goes left, I'm going down. As x goes right, I'm going up. Pretty simple, pretty simple. Perform these. That's going to take a while. That's fun, okay? So no worries. Number 4 is, so we just got to distribute. You can do this both ways. I like to do it the first way. So I'm actually going to distribute the second one to the first one. So I'm going to distribute that. So I'm going to multiply 2r times 7r squared, 2r times negative 6r, and 2r times negative 6 equals. And then I'm going to do the second one, 4 to distribute to everything. So I've got 4 times 7r squared, 4 times negative 6r, 4 times negative 6. Right, then I just do it. So 2r times 7r squared is going to be 14r cubed. This one's going to be negative 12r squared. This one's going to be negative 12r. And over here I have 28r squared. Negative 24, sorry. Going too fast. Negative 24r. And negative 24. Right, then I've got to combine all of it. I'm kind of running out of room, but that's okay. I'm going to combine them. I'll write it up here. So 14r cubed, that's the only one. Then I've got to combine these, which will give me positive, 16r squared. Then I've got to, so those are done. Then I've got to combine these, which gives me negative 36r. Those are done. And then I finally just have a negative 24 at the end there. So that's the answer to number 4. On to number 5. I'm just subtracting. Easy peasy. So I'm going to distribute this negative so that I could just combine like terms, since that's a lot easier than subtraction. So I'm going to rewrite the first one. And then distribute this negative, so I've got negative 4x squared. That is a plus, it looks like. So this will become negative 5x, and this will become positive 6. Then I just combine. There is no other x to the third term, so 5x to the third just drops. Negative 7, negative 4 combines to make negative 11x squared. Negative 5x is by itself, so it just drops. And then negative 8 and 6 will make a negative 2. Easy. Right, division. How fun it is to divide by you. So yeah, let's just do it. Pretty simple. So I've got h squared. Remember, the process isn't hard, guys. It's just tedious. Sorry. But the process itself shouldn't be too hard for you. Let me write it out. Okay, so remember, all you're worried about are the first terms. So let's use a different color. So this guy and this guy are all I'm worried about. So I asked myself, what do I multiply h squared by to get to 3h cubed? I've got to get the coefficient to a 3, so multiply by 3 coefficient, and then I need one more h. So that's what I put there. Then I've got to distribute this to this whole term, this whole divisor. So I get the 3h squared cubed that I was looking for. I get negative 6h squared, and I get positive 6h. Subtract it. These cancel. This will subtract so that this turns into a positive, so then I get 2h squared. 2 minus 6 is negative 4h. drop down the 4, positive 4. And then I do it all over again. So, h squared, oops, is my first term. My other first term is 2h squared. What times h squared gives me 2h squared? Well, that's easy. That's just 2. Then again, I just distribute here. So, 2h squared, 2 times negative 2h is negative 4h.
I'm hoping it'll get through that many for me.
I don't know. Goins was saying that the copier was jacked up.
Close that. That is closed. 2 to 2 sides. Come on, baby. Come on, baby. Where are you messing up? Paper tape inside the left side door. Alright, so.
The science one's all messed up?
It's saying that I have a paper jammed here. You know what it probably is? There was a jam, and there's like a tiniest piece of paper stuck in here. I'll bet you is what it is.
Who knows? Those things are always broken.
Ha!
There it is. The copy machine guru.
Come on. Alright, you down, you there, you there. That's all I gotta say about that.
Oh, you did it!
Bam!
Copier's working. Crowd goes wild.
So one thing I learned from the copy guy that comes in, if it's continually jamming, take the entire stack of paper, flip it over.
What?
I don't know why. I guess it's sometimes when they're in, they'll warp ever so slightly.
Huh.
So they'll warp slightly like
Yeah,
that.
yeah,
Just flip them over. Just
And that
flip it
does the
over.
job. There
And
you
it
go.
worked. It did it.
Fair
It
enough.
got me my 30 that I needed. So, something to remember.
Duly noted. Well, sorry about that, guys. Remember, we're subtracting. Hopefully you followed along so far. So remember, we're subtracting, so this is going to be negative 58x. And then we got to bring down this negative 3. This is turning into a real doozy here. I'm not liking this at all. Yeah. That's the way it goes, though. Okay, so that's fine. So then negative 58, so that's what I've got to multiply by. So I'm going to change back to red. So negative 58 is what I'm multiplying by here. Oh, look at that. Then I got to distribute it, so I get the negative 58x, and I also get negative 116. So these will cancel. This will turn into a positive because I'm subtracting, so I'm going to end up with 113. And that's my remainder. So my answer is just going to be what's up there. So my answer here is 5x cubed minus 11x squared, and I might run out of room here, so bear with me, plus 29x, that's a plus sign, minus 58, and then I'm going to add the remainder down here. It should all go in the same line. Add 113 over our divisor, which is x plus 2. So all that is the same answer, and that's it. Right, that's it. Yes, it was a lot. Yes, it was tedious, but it's very doable. Very doable. Okay, so just kind of take your time with those division problems. Make sure you're not making any silly mistakes, and you should be good. Right, you should be good. Here, remember, guys, once you know the degree and the leading coefficient, these end behaviors become very tedious, right? It's the same stuff over and over. So again, you need to know, I would just circle the biggest term, circle the highest degree, so that way you know what you're talking about. So this one, this is the highest degree, that's all I care about. This and this I don't care about, right? So I have a negative, I'm sorry, I don't know why I said that. I have an odd degree, which means my end behaviors will be different, and I have a positive leading coefficient. So it's going to behave just like x to the third. Oh, that looks terrible. Just like x to the third, like that. So it's going to behave the same way as that. So as x goes to negative infinity, my y goes to negative infinity, just like my x to the third does. As my x goes to positive infinity, my y goes to positive infinity. Right? Yeah, simple as that, guys. Simple as that. So that's every time. This one here, this is the only one we're worried about. I have an odd degree, a negative leading coefficient. So it's going to look like negative x to the third, which is just like this. A little bit better, actually, but that's fine. So as my x goes to negative infinity or goes left, my y is at positive infinity. And as I go the opposite direction, my y will go the opposite direction. Simple as that. Right? Over here, my highest degree is right there. Again, these don't matter. So I have an even function with a negative leading coefficient, so it's going to be like a negative x squared, which goes down. It opens downward. So as my x goes to negative infinity, my y goes to negative infinity. And same thing, as my x goes to the right, or positive infinity, my y, again, goes to negative infinity. Right? This one here, this is the highest term, so these don't matter to us. We have an odd function with a negative coefficient, so it's going to be just like this one here. Same thing. Right? So my end behaviors are the same. I start up top and I end going down. Here, 18, I've actually got two that are to the sixth, so I've got to combine those like terms. So really what I have is a positive x to the sixth. That's my leading coefficient. That's my leading term. So it's even and it's positive, meaning it's going to look like a parabola. I should really zoom in on this, so I could have written it better, but it's okay. So it's going to look like a parabola. So as my x goes left, or negative infinity, I don't know what I was doing. My y goes up, or to positive infinity. And as it goes right, or to infinity, my y, again, goes to infinity. Last but not least, this is our leading coefficient, or our leading term. Degree is odd. Leading coefficient is positive. So it's going to look like x to the third, which we draw in number 1, but it looks like that. So as my x goes left, I'm going down to negative infinity. As my x goes right, I'm going up to positive infinity. Pretty simple. Pretty simple. Okay. I haven't got too much time, so I don't mean to rush, but this stuff is pretty simple. You can kind of slow it down, repeat it as you need, but it's pretty simple. Okay. All right. So 20. We're just going to reason through these, guys. We're going to reason through it. So our degree is even. It's x squared, so it's going to look just like a parabola. I'm sorry, I lost my train of thought. It's going to look kind of like a parabola. It's even. It has a positive coefficient, so my end behavior is going to be positive infinity to positive infinity. Right? So that means it's going to look like this one. It could look like this one. That's it. One of those two. So, Yeah, that's it. One of those two. So I'm just going to plug in 0. Actually, both of them go through the origin. That's great. So it's going to be one of those two. Yeah, I mean, it's a parabola because it's x squared. So it's pretty simple. It's e. Right? It's got to be a parabola because it's x squared. D has a little bit of waves in the middle. A parabola will not have that. So x squared is e. No big deal. Let's move on. Okay, so number 21, 1 over 2x plus 2. Guys, this one should be easy. It's just a linear function. It's I right there. It's going to be increasing, and it's going to be like a small slope because it is a fraction. So this one's just I. Easy. 22 is also easy. It's another linear function. That one's just going to be a. I'm not going to waste time explaining that. 23, an odd function, right? It's going to be like a cubic with a positive leading coefficient. So my end behavior should be negative infinity on the left, positive infinity on the right. This one's got way too many things involved to it, so it's either going to be H or F. This one's got way too many humps involved, so it's going to be a higher degree. So you could just go through F right there. It's going to be F, right? It's going to be F. Sorry. Let's erase this stuff. 24. Different color. 24, negative 2x squared minus 5. This one should be very easy, guys. This one's just transforming the parent function. Like we've talked about, transformations will not leave. So negative means I'm flipping across the x-axis. Minus 5 means I'm going down 5. That looks a lot like B, right? Sorry, I'm putting my palm down, so it's not working. So that's B, right? Pretty simple. Pretty simple. Oh, goodness. What the? Okay. This is starting to lag, sorry. So, 25, x to the 4th plus 2x to the 3rd, even degree, positive leading coefficient. So it's got to be this one, right? We already did E, so D is the only one left, so it's got to be D. Oh, my God. Okay, let's change the marker again. Negative 1/3 x to the 3rd. So odd degree. Let me mark out the ones we've already done. So that one's done. I is done. A is done. F is done. B is done. And D is done. Okay. So the only ones left. Negative 1/3 x cubed. The degree is odd. The leading coefficient is negative. So this one can actually only be one of them. G is the only one that matches that. So G is the only one that matches it. So I only got 2 left. One's odd, one's even. So I really don't even have to do much more work. But I will anyway. Negative 1/4 x to the 4th. That is an even function, meaning the end behaviors will be the same. And it's negative, so it should be facing downward. That is C. Then finally, H here. X to the 5th is going to have a bunch of humps in the middle. Leading coefficient's positive. So there you go. Yay. So I only have a little bit left. I will do this after school because the bell just rang and I have 8th period. So yeah, I'll be back. You won't know though because I'll just pause and resume. So none of this is necessary. Okay. All right, so I'm here in my 8th period class. They look at me in their natural habitat. I observe. Yeah, I'm FaceTime. My 2nd period. No, I'm not FaceTiming. I'm doing this. Okay. So, this is awkward. Okay. So first, these critical points for increasing and decreasing, like I said before, is local. Is local. Jeez. I can't write. Local max and min. So this interval from negative infinity to positive 4 has got to be increasing. Okay, so I'm going to put a dot there. And this side's got to be going like this because it's got to be increasing on the left. And then my other critical point is going to be at positive 6. And that is decreasing. And then f is increasing after that. So I've got to be increasing right here, decreasing here, increasing here. But I don't know how yet until I know my x-intercepts. So my x-intercepts are the intervals of positive and negative. So these are my x-intercepts. So my x-intercepts are going to be -5, which is going to be right here. -1, which is going to be right here. 8, which is going to be 1, 2, right here. And that's it. So now I have enough information, right? That's white. That's silly. Okay. Now I have enough information to draw my whole graph. So I know on the left of this blue, it's going to be increasing. I'm talking low so you don't hear me. This is embarrassing. It's going to look kind of like that. Obviously, it should be drawn better, but I'm nervous. This is the first date, kind of nervous.
They're going to hear all of our conversations on their own.
They don't care about your conversations.
Yeah, some people do.
I'm just kidding. Wow. Okay. Okay. So then after drawing that, obviously it should look a little bit better than that, but that's fine. Anyways, so once you have the kind of rough draft drawn of the thing, you can kind of debate on what the degree is going to be. If it has different end behaviors, it's going to be an odd function, and the leading coefficient, since it starts on the bottom, ends on top, the leading coefficient should be positive. Woo! Okay. Then expand binomials. And the last ones are like this. So you just expand x plus y to cubed to x plus y times x plus y times x plus y. And then combine like terms. So I'm not going to do these out. Going to take forever. But just kind of cross-reference your answers to mine. And you should be good. Okay. Well, that's the review. All done. 8th period, you want to give me a round of applause?
No.
Woo! Good job. Also, 8th period was talking mad mess about y'all. Mad mess. Okay, bye.